Hi, everybody. I want to extend my thanks to Brianna and to the organizers of Augmented World Expo 2022. It is such a thrill for me to be here in person again after, a few years from the pandemic. I know that we were here in November, but it didn't quite feel the same way as it does for this week. And it's really nice to have some normalcy here.
Yeah.
As Brianna introduced me, I am Kathy Grise, Senior Program Director for IEEE, specifically Future Directions. Before we get started on the panel at heart here, I wanted to advise people, like, if you haven't heard IEEE, and Brianna did a great job because she pronounced the acronym correctly, but if I hear somebody say IEEE, then I know they're not familiar with IEEE. And let me explain quickly on that. We originally were called the Institute for Electrical and Electronics Engineers, but since then we're simply known as IEEE. The reason behind that is we're more than just for electrical, mechanical engineers. We literally have computer scientists, clinicians, practitioners, neuroscientists, the full range, data analysts, data scientists now. We are the largest technical, not-for-profit organization globally. We have over 400,000 members. What we do is we look at new and emerging technologies to advance the benefit of humanity. Some of you may think of IEEE as only on standards because we drove towards the 802.11 standard, which allows any of you that have a cell phone, and I suspect all of you do, we enable the providers to be able to talk to each other. Can you imagine how critical that is? If we didn't have that today, right, you wouldn't be able to communicate with each other. Some of our past members date back to Thomas Edison and Marconi. So that just gives you a perspective of what IEEE is. We also work on conferences, education, and publications. Then it leads me to why I'm here. I'm part of a small group called Future Directions. We have a small committee where we look at new and emerging technologies that IEEE should play in and become thought leaders. Future Directions looks at currently now things like blockchain, quantum, digital reality, which comprises of the digital transformation, AR, VR, XR, MR, 360-degree media, all things that you've seen this week at AWE. AI, ML. Imagine the amount of data that has been generated. I mean, we've been generating data for decades, right, for centuries, but we've reached that next level of data where it's just exploded. We're now into the yottabytes, zettabytes, right? So what do we do with all that data? It's really becoming more intelligent to leverage that data and making sure it's the right data. And you'll hear some perspectives from my panelists here in terms of that. And so really it's making that intelligent decision making and other aspects that are not necessarily related to technologies. So that is the IEEE Digital Reality Initiative. So that's a quick overview of what IEEE does, what Future Directions does, and what the Digital Reality Initiative does. Now I'll go into the heart of our panel today. It's all things in terms of IEEE engaging with immersive and intelligent realities. And you're thinking, okay, what does that really mean to everybody here? And that's where my colleague Tom Coughlin from Coughlin Associates and Nick Napp from Xmark Labs will share their perspectives, their observations, and maybe even some predictions. So first off then, I'd like to invite Tom. Please introduce yourself a little more, and how do you fit into this digital reality initiative?
Sure. So I'm Tom Coughlin. I'm president of Coughlin Associates. I've also been an IEEE volunteer, and I've been involved in the Digital Reality Initiative since its start and its earlier name. I am actually involved in digital storage and memory consulting. I put on events. I'm actually program chair for the Flash Memory Summit this year. I write a blog for Forbes.com on storage and memory and applications, and I really see that these new, more immersive technologies have had a real boost. First of all, because of the recent pandemic experience, but as the technology develops, I think it's going to become the ubiquitous way in which we communicate and interact with each other.
Super, Tom. Nick?
So I'm Nicholas Napp. I run a small consulting firm called Xmark Labs. We cover a range of things that fall within the digital reality spectrum. Personally, I've been working with VR, actually practical applications of VR since the mid-1990s, if you can believe that, and AR since about 2008. I actually had an NSF-funded startup looking at doing AR on mobile phones back in 2009, which turned out to be a bit tricky. It's much easier now. But throughout my career, I've worked in different elements that all kind of contribute to immersive reality. And I think one of the things that Future Directions does that's a little different is, as the name implies, they try and get a little ahead of where we are now. And right now, I think we are very much at the point where we're all starting to believe that the immersive nature of AR, VR, MR, XR is working, right? And there are clear, tangible benefits that we're starting to see, and the tools are reaching a point where you can do useful things without spending $1 million every time. But you have to ask the question, what's next? And as Kathy hinted at, right, we're all drowning in data. I think one of my favorite internet stats is now every 2 years, we create half the data in the world. So it is literally an exponential growth curve. And that's great, but how do you process all of that data? And I don't mean process in terms of machines grinding away. I mean you as an individual, right? You are continually surrounded by more and more things that you know less and less about. And if we don't figure out a better way to bridge that gap, we're going to get pretty lost pretty quickly. So when I think about immersive reality, to me, that's the next step where not only, or intelligent reality, I should say, not only is it immersive, but it is far more responsive and understanding of your specific needs in a given context at a given point in time.
That's great. Although I challenge you, maybe next year we'll talk about this. You said every 2 years? I don't know.
Yeah, I think it's accelerating. So.
All right. I have a question here for Tom. Throughout AWE this week, you've seen a lot of interesting and cool new technologies and their implementations, but we're still into like the hardware, the software, and the various devices behind that. What do you see, though, in terms of like the application and long-term sustainability factors behind that?
So, this is a method for us to interact with each other, interact with our machines, in a new way. I think, that has a great deal of value. It's going to drive demand for this, but that also is going to have implications in terms of the amount of energy, for instance, being consumed. In data centers, for example, like the latest NVIDIA GPU runs at 800 watts, and they're talking about the next one being over 1,000 watts, and going to liquid cooling, things like that. Right now, data centers use about 1% of the world's energy generation, but they're talking about that going to 8% within a few years' time. That's a lot of energy being consumed. So I think new architectures and technologies which can reduce the consumption of energy, both in the large scale and the data centers at the network edge, and also in endpoint devices, like watches, phones, smart glasses, things of that sort, is going to be critical. Some of these are going to involve development of new energy sources in the way in which you use energy, in data centers in particular, because they generate so much heat, for example. How do you get the heat out of there? How do you generate energy? What do you do if you're using renewable energy? What do you do at night when the wind isn't blowing? So there's a lot of factors that are going into how we do that. But the other part of it is the actual design of the data centers themselves. There's new developments. About 60% of a server's energy consumption is actually in moving data around. So moving to more domain-specific processing capabilities where we process data closer to where it lives is going to be an important element in designs. There's new designs in memory interface like CXL that's going to play a big role in that, as well as allowing you to do pools of memory, break up servers and parts and then put them back together again into a composable infrastructure that are going to allow more efficient use of these things. Maybe going from volatile to non-volatile memories, because refreshing the energy of DRAMs, you have to do that all the time, and that could be a big factor in servers, especially if you're doing a lot of AI-type processing, maybe another element that happens. On the consumer devices, we're working off of batteries, very energy-constrained situations, and so there is a big movement now, both because of lithographic constraints on NOR flash, but also because of the demand of being able to do more processing with less energy, of using things like magnetic random access memory technologies in embedded devices that replace the NOR flash and can replace some of the SRAM. It's non-volatile, so I can go into more low power states when it's not being used, but then come back up right away. And then also, if you go to the edge side of things, you're also somewhat power constrained, and so there's developments there I think that will help as well on creating more sustainable infrastructure that's more efficient, get more done with less, and helps us to keep within the affordable budget to be able to make the technologies, these immersive technologies, real for us, which involves both AI as well as display technology.
Tom, that was interesting. I wanted to touch on a little more where you talked about the importance of data centers from an enterprise level, but are we really still having data centers per se? I mean,
they're building more of them.
Okay.
Yeah, but there also is being more stuff built out at the edge of networks, but that's still in a nation stage, and the standards aren't very good. There's a lot of building smart cities, for example, where you have a lot of intelligence built in the infrastructure. There's still a lot of work needs to be done to make that possible. And that will be an important element. So if you're going to be interacting with your environment, for instance, is the city. If you're on the road, it's the highway. Building the capabilities where I have low latency processing, memory storage processing, and networking capabilities that are dispersed in probably energy-constrained situations, building it up, getting them so they work well with each other. We're still a few years off being able to make that possible. And these, I think, are some of the enabling capabilities that are going to make this immersive technologies be more and more useful to us.
Yeah, you missed it earlier, but we had a speaker, Marcus, at the main stage, and he actually developed and manufactured a carry-on bag that allows one to have an immersive experience broadcasting. I'll have to show you that one. It was pretty cool. Yeah, he had his own little mini green screen and a little camera, and it's just based off your usual.
So he is an edge or a data center, perhaps.
He's his own data center.
That's
yeah,
right.
yeah. Thanks, Tom. The question for Nick.
So, go ahead.
Oh, no. Give me a chance. I didn't ask the question.
I thought it was the same one. No, go ahead.
Nick, you're a gamer, both at heart and real practice, but you're also a developer. So you bring different perspectives, both as a developer and an end user. We've talked a lot about technologies at AWE, but from your perspective, what do you see some of the challenges, and what can we do to really help and enable this?
So I think one of the dramatic changes for enterprise software in the last decade really has been the impact of the smartphone, right? Because if you go back to the early 2000s, most enterprise software was beyond unusable, and we all just accepted that as the norm. And then largely through gaming, but complex apps on smartphones, we've come to expect that when you sit down in front of any software application, you know how to use it fairly intuitively and fairly quickly. And there are still plenty of holdouts in the enterprise space where that's not the case. But I think, especially in immersive reality, we've still got a lot of interaction design issues to figure out. Haptics, I think, unfortunately, is still very poorly solved, right? And if you can't touch things, that tends to make a lot of interactions a lot more complicated. But sort of stepping back and looking at the bigger picture, we still have fundamental issues, I think, in terms of cost and complexity that aren't solved yet. So, for example, at Xmark, we ran a pilot a couple of years ago to explore VR training for small to medium-sized manufacturers. So these are companies that are doing anywhere from, say, $50 million in revenue to a couple of $100 million. So not tiny companies by any means, but using the tools that were available, it simply was not cost-effective to develop VR training for manufacturers of that size. It just, for the number of processes that they typically had in-house, to replicate those in VR was just way too expensive. And digital twins are very much the same, right? If you're looking at a industrial digital twin, you know, if you've got pockets like a Boeing or a Raytheon, great. You can sign up, you can spend your $1 million and come away with a shiny digital twin. If you're running a 150,000 square foot commercial building that maybe is a few years old and doesn't have a centralized building management system, good luck. You're going to drop $500,000 probably with a very questionable rate of return. So one of the areas that we've been working on is lowering the cost of getting the initial sensor data in buildings that need retrofits. Because right now it costs you about $7 a square foot. And it's incredibly disruptive to the people that are working in the office because some guy has to come in or gal with a drill and drill holes and lay cables and so forth. So that's one area that we've identified as a company to say, you know, if we can radically drop the price, like 80% on the sensor input, and then use some of the newer tools to create the digital twin, we believe we can drop the cost of creating a digital twin by at least one order of magnitude and probably two. So take it from being a $500,000 proposition to a sub $5,000 proposition. And at that point, the return on investment for the companies looking at it becomes much, much, much simpler.
You touched on it a little bit too, that made me think, as a result, exacerbated from the pandemic, the supply chain. It's not just other costs, right? What do you think on this issue?
Yeah, I mean, it's funny because when you talk to people about supply chain, they fairly quickly fall into two camps. There are the people that believe that we can do it all ourselves wherever you're based, and I've had that conversation with people in the UK, in the US, in India, in parts of Asia, and there's a belief that, yeah, we could actually just do it all here and streamline this whole thing. And then you get the people that live in the real world that understand that materials are spread to the four winds, and processes and process expertise is spread to the four winds. To give you a current metric for a PCB that we were recently designing for an IoT device, to get the same exact device made onshore in the US versus offshore in a short-run PCB company in China, it was literally 10 times more expensive. I think we paid $600 to get it done in China. The quote was $6,000 in the US, and they wanted 12 weeks, and I got it back in 3 weeks from China. So there is such a disparity because China is so incredibly vertically integrated, they can do this kind of thing very efficiently. And there are areas where, you know, the US can be better and the UK can be better and other places can be better, but we can't all be the very best at everything. Not to mention that the materials themselves that we're using, you know, whether it's rare earth materials or plastics or whatever, are not growing literally everywhere, right? So I think complex supply chain is a problem that is not going away. There are some interesting applications of things like blockchain and digital twins applied to like an entire supply chain that are pretty promising in helping you spot errors and challenges early on. But yeah, I think it's a problem that gets worse before it gets better, for sure.
And that's where IEEE, the Future Directions, has an initiative on blockchain. So, yeah, cool. Here's a question for Tom. As we've walked around the exhibit floor, we still see a lot of the handheld devices that are still pretty clunky, right? Particularly with the VR experience, where you really can't see out. You're totally blocked and forced to see what is within the headset. But then we've also seen now some pretty cool looking glasses, frames, that the form factor is much improved.
They're getting there.
Yeah, yeah. I was going to say you want a set, right? And then
Yeah.
from a gaming perspective, I was thinking like there's Leia that just uses, like monitors your head movement and it provides that 3D experience, which I thought was pretty impressive. So in that case, you don't need hardware. Or the Tilt 5 game that we saw recently where it's a much better user experience. But from your perspective then, as a personal device, right? What's your thoughts on that? Are we going to get to a point where do we really need a device? And there's implications, right? From a home use perspective, from commercial, like on the manufacturing floor, in an operating room, to just simply being outside. So what's your thoughts on that, Tom?
I think it's two sides. One is, how can you minimize the number of pieces of equipment that you've got to be able to do something? If I've got
And not an implant, right, in your head.
Well, that'd be the cheapest, the most effective way of doing it. Right? Just do it right to the brain, right? But assuming we're not there yet, right?
I hope not.
There's that. So can you do it with a minimal amount of technology, which actually might be good from a sustainability point of view, or do all these display devices and ways in which we can interact with other things, is it good to have these dispersed around? And I think there's arguments both ways. Sometimes having the single device might be good, but a lot of times there's going to be different experiences, different things you can do. In the second case, of course, then just like, for instance, IEEE has been involved in standards on interface technologies, also creating standards where I can say move something from one display or one view to another view, another type of display device. We need things like that, so I can physically, it looks like I'm just moving something from one thing to another. And then to understand, of course, making sure we get good communication between those things and low latency levels. The other side of it is that there's enormous advances going on in photonics right now. Right now, photonics, of course, is used as the high-speed networking infrastructure in data centers and long-haul communication. But increasingly, it's now being used within a data center, rack to rack. And there's work going on now to have chip-to-chip and inter-chip actual communication using photonics. If you start, the big issue, of course, is making the devices small enough to do the photonics things. But if you can tackle that, which over the course of time might be able to do that, it might be possible that every transistor effect or every piece of functional circuitry could actually have a pixel built into it, possibly a display device. So things like this could make it possible to make everything with a display device, for instance, clothing, and so things like that could have very interesting impacts on us. So, is it going to be minimalist? Is it going to be maximalist? In other words, everything becomes display. I think both are possibilities. They have different functions and uses, and it'll be really interesting to see how that all develops, based upon material science, based upon computer architecture standards for these things interacting with each other.
Cool. You provided a beautiful segue to my next question here, and that's about standards. And I'll start with Tom, since you introduced that topic. IEEE is not known for just standards. Clearly, they're leading the way on that, but also there's technology roadmaps, which I think is critical and very important to enterprise and industry. Can you share then, for those of you that are not familiar with standards roadmaps, what does that really mean? What's the value and the importance behind those?
So some people probably heard of something called Moore's Law, which effectively was, has been guiding advancements of transistor densities in electronic devices. In a sense, that was a kind of a roadmap. It's not really a law; it's more like guidance on, Gordon Moore saw that there were trends in terms of what was the advance in lithography and the complexity of chips to be able to make more stuff in smaller spaces. The Semiconductor Industry Association had something called ITRS, which is a standards group that's working on, for instance, semiconductor standards. That has now actually been adopted into IEEE. And there's an IEEE, IEEE now has IRDS, the road mapping activities, which is associated or part of Future Directions, which is driving not just the semiconductor technologies, but a number of basic technologies. What this does is you get experts from all over the world who are involved in talking about where things are going to go in the next, say, 5 to 10, 15 years time frame. These are extremely important for guiding our development and also for getting people together, working on things. And I think eventually it leads into public policy, it leads into corporate spending on development of different approaches, and it creates new creativity, I think, and new spurs for discovery and development of concepts that make that possible. I'm actually involved I've been doing a mass storage roadmap, a biannual thing with IEEE, and we actually moved that to IRDS this year. So it's including a lot of the basic nanotechnology, semiconductor technologies, where things go in the future, but moving into other spaces as well, networking, mass storage, and a number of other areas as well. These are actually available. You can see them on the website. Look at the IRDS, IEEE IRDS. You can find a lot of these roadmaps, at least last year's and this year they're working on it.
Or roadmaps.ieee.org.
There you go. Okay.
All right, thanks, Tom. This will be my last question, kind of elevating not so much on straight technology, but there are so many things that we have to consider, and I know IEEE is really involved in this too. It's more than just the technologies, but how we use it and apply that, and I'll address this to Nick, is what are like social, ethical, legal implications? You know, we talked about responsible AI earlier, bias, right? And so, Nick, why don't we kind of finish that?
All right. Well,
2 minutes.
I was going to say, given that we've got like a minute and a bit.
Yes.
So I'll just focus on one area that I think is chronically misunderstood. And I would preface all of this with saying that tech tends to be incredibly forgetful. For whatever reason, we do not learn from the lessons of our own past. And one of the areas that is very clearly a train wreck that is already happening is digital privacy. And I don't just mean individual privacy, I mean across the entire ecosystem. We have regulations that are hopelessly out of touch with how data is used. We have various very large companies that are making enormous sums of money from the data that we are freely handing over. For those of you that are based in the US, I heard an interesting story the other week about pleading the Fifth Amendment, right? So if you plead the Fifth, for those of you that haven't ever seen a Hollywood movie, right, it's basically your right not to self-incriminate, right? If you've done something or haven't done something, but you don't wish to comment on it because it could be perceived as incriminating you, you have the right to not self-incriminate. That does not apply to your digital device. If you have your smartphone and it is generating metadata or other data, Google searches, whatever, that in some way might incriminate you in the US, you have no Fifth Amendment protection. And the reason that you have no Fifth Amendment protection is because the courts consider that you waived that right based on all of the data rights that you granted the phone operator and the operating system, whoever made your operating system, the telco and the apps that you've loaded on your phone. Every single one of those privacy agreements is so broad and so grabby that the courts look at it as third-party doctrine and say, hey, you've already waived your right to privacy, so we can just come in and take that data. That's a pretty awful state of affairs, and it's not getting any better. And beyond that, just our whole way of thinking about data and data privacy needs to be reset. Any of you that lived through the early years of the dot-com era with Napster and copyright and so forth saw the big mess that created. That is the tip of the iceberg compared to digital privacy. So I would encourage all of you to spend more time thinking about how we can educate, especially the politicians, to be a lot more aware of the challenges that's going to present.
Thanks, Nick, and you certainly touched on a whole new topic in terms of politics and everything. I'm not touching there. So we are out of time, but I wanted to encourage you to that Future Directions launched a new initiative this year on digital privacy. So if you want more information, go to IEEE.org/Future Directions. It's all one word. And I want to thank Brianna here for hosting us, Augmented World Expo. Thank Tom and Nick and all of you for your attention and participation today. Thanks much.
Thank you, Kathleen.